All right, starting lesson 1.7, angles and congruence. An angle, and here's the symbol for an angle, it's a slanted L, consists of two rays that have the same endpoint. Okay, so two rays, call this AB, and here's the second ray, call it AC. Okay, and the rays are known as the sides of the angle, and the shared endpoint of the rays is the vertex of the angle. Now an angle can be named using points on its sides or by a number. We could also put a 1 here and call that angle 1. Let's go through a couple examples of how to name angles. State all the different names for the angle below. Well, we could call it RST. It's just like as if you're walking around the angle. We could call it TSR. We could call it angle S, since there's no confusion in this case, angle S. Or we could call it angle 2. All right, now for example B, state all the different names for the dotted angle. Note, angle M is not a name of the dotted angle because there are three angles that angle M could be referring to. So we can't use angle M in this particular scenario because we wouldn't know what angle we're talking about. All right, so state all the different angle names for the dotted angle. So this is HMN. Or it could be NMH, or it could be angle M. No, it can't, because we don't know which angle that is. It can't be angle 1, it can't be angle 2, so that's all we have to go by. So that's when you have to use 3 points to name the angle. Otherwise, you have no way of telling which angle you're referring to. All right, shade the angle that is indicated. Angle 1. That would be this angle here. All right. XYZ. XYZ. That's going to be this angle here. All right. Notice the vertex of the angle is the middle letter. Then we have LNO. LNO. That's going to be this angle right here. Okay. The measure of an angle is written in units called degrees. All right, and then you have like the little tiny circle, which is the symbol for degrees. An angle can have a measure between 0 degrees to 180 degrees. The notation, this here, means the measure of angle A is equal to 82 degrees. Now for example 3, we need to construct an angle with the information given. So you're going to be using a protractor for this. Now how to use the protractor exactly? So here they give us this segment. So we will line up the point with the middle of the protractor here. And this is what we have. All right, and we always start from 0. So we're going to start with the numbers from the inside of the protractor. So 0, 10, 20, 30. So that's going to be my angle then. Okay? So you would draw a little dot outside here and use your protractor or ruler to draw the line. So it's something like that. All right, that's your 30-degree angle, and it's A. All right. For the next one, ABC is 125 degrees. Notice that the arrow is pointed to the left here, so I start from here. Okay, you're actually going to put your protractor over the line. All right, and let's see, I need 125 degrees, so I start this time from the outside numbers, and I'm going around 10, 120, and then 125. So I put a dot there, and then I would draw my line. All right, so it's going to be something like that. And I'm going to have A, B, and C. And that's going to be 125 degrees. All right, let's do 2 more examples. Here I'll use my protractor, and I'll have a dot straight above. End up with something like that, 90 degrees. And I could call this D, E, F. All right, for the next example, 180 degrees, that means I'm looping around, and I'm just going the opposite direction. So I could call this X, Y, and Z. Okay, that's 180 degrees. All right, come up with an approximation for the given angle. Okay, we could call this here roughly 45 degrees. Once again, it's an approximation. So you should be able to tell the measurement of the angle just by looking at it, roughly. And we could say this here is around 135 degrees, and this is 90 degrees, and this would be 180 degrees. All right, you should have a general idea of what the measurement of an angle is just by looking at it. Okay, now there are 4 types of classifications. An angle can be given based on its measure. So you can have an acute angle, which is less than 90 degrees, obtuse angle, which is greater than 90 degrees, a right angle is equal to 90 degrees, and a straight angle is equal to 180 degrees. So classify each angle. This would be a straight angle. This would be a right angle. This is less than 90, so this would be an acute angle. And this is greater than 90, so this would be an obtuse angle. All right, now in geometry, the word congruent that's the symbol for congruence, just the equal sign with the squiggly line above it, is often used, which means to have the same size and shape, or to be overlapping. In other words, it roughly means to be equal. All right, but when we say equal, we're referring to actual numbers. All right, congruence has to do with shape. Now, tick marks are used on a diagram to show segments are congruent, and arcs are used to show angles are congruent. Let's see some examples of that now. Now label the diagram using the given information. All right, now this means segment AB is congruent to segment AD. So AB is congruent to AD. That means they have the same length. All right, BC is congruent to DC. So BC is congruent to DC. I'm using 2 tick marks in this case because I don't want to confuse it with the segments I just worked with. So that's going to be 7 as well. Now line K bisects XY. Bisects means it cuts it in half. So that means these 2 portions are equal to each other, so they have the same length. M is the midpoint of CD. So if it's the midpoint, it bisects the segment as well. These 2 lengths are the same. That's going to be have a length X as well. Angle 1 and angle 3 are congruent. So we use arcs in this case. That shows that they're the same. Angle 2 and angle 4 are congruent. So we're going to use double arcs here. All right, BC bisects ABD. So that means it cuts ABD in half. That means these 2 angles are the same. I'm going to offset the arcs so it's not one continuous arc. And so this is also 55 degrees here. And then I have angle FGI, that'll be this angle here, is congruent to angle HIG. All right, those are the same. All right, couple more markings we have to do for diagrams. AB is congruent to BC, which is congruent to segment AC. So these are all the same. Then it says angle A is congruent to angle B, which is congruent to angle C. All right. Angle ABC is a right angle. So we put a little box there to indicate that ABC is a right angle. Sometimes one arc can be used to show the measure of an angle that contains an angle inside of it. So if I have one continuous arc going across, and then you have a number next to it, that means the whole angle is 84 degrees. Example 7, write a congruent statement based on the information depicted in the diagram. Okay, now both of these segments have the same length, so I would say segment AB is congruent to segment BC. For part B, these angles here are congruent since they both have one arc each. So angle ABD is congruent to angle CBD. And for angle C, or part C, I have all of these angles here are right angles. They're all equal to each other. So angle 1 is congruent to angle 2, which is also congruent to angle 3, which is also congruent to angle 4. All right, so we're diving into angles now. We're working with the idea of congruence. If you have any questions, make sure to ask. Begin the assignment.